question 2. We've got A, B, C, and D are the vertices of a triangle. Oh, sorry, that's supposed to be a rectangle. A, B, C, D are the vertices of a rectangle. A, B, C, D. AB is equal to 5 units. The angle of inclination of AD, the angle of inclination is theta over there, as shown in the diagram. And then also, they don't give you B's y coordinate. They say it's 0k. 0k. Okay. 2.1, calculate the length of AC. So AC is that length. We've got the coordinates of A, we've got the coordinates of C, so we just use the distance formula. Um, 2.1. So I'm going to go straight into substituting it. So the distance of AC would be, subtract the x's from each other, 3 minus the negative 8 squared plus 2 minus 0 squared. So that is 11 squared plus 2 squared. It's 121 plus 4. That's square root 125. Okay. Calculate the value of k. Okay, so AB is 5 units. So they already give us the distance there. So if we were to substitute all of this in the distance formula, the only unknown would be k, and then we will be able to solve for k. Okay, so I'm going to plug that into the distance formula. So the distance of AB we already know is 5. Yeah? Now the x's, 3 minus 0 squared plus 2 minus k squared. Okay, now to get rid of the square root, no, sorry, let's okay, let's not do that. So to get rid of the square root, I will square, né? And then I have to square on that side as well. So that's going to be, okay, so let's do that. So we're going to square that, and we're going to square this whole thing to get rid of the square root. So that's 25 is equal to, and that would be still 3 squared plus 2 minus k squared. So that's 25 is equal to 9 plus, okay, let's times this out. So if this means it's 2 minus k times 2 minus k. So 2 times 2 would be 4. 2 times negative k is negative 2k. And then again 2 times negative k, that's negative 2k, so that would make negative 4k. And then negative k times negative k would be positive k squared. Okay, right. And now we just write it neatly in descending powers. So k squared would come here, minus 4k. 9 plus 4 is 13, minus the 25. So that's k squared minus 4k. 13 minus 25 is negative 12. Okay, so now we have a quadratic equation, which we can now factorize and then find the answers for k. So because it's negative, I know it's going to be plus minus k and k. Okay, what times what can give me 12? But if I add or subtract, gives me 4, 6 and 2, no? 6 and 2. So because that 4 is negative, larger number will be negative, smaller number will be positive. So 6 goes there, 2 goes there. So k plus 2 is equal to 0, or k minus 6 is equal to 0. K is either negative 2 or k is equal to 6. So looking at our diagram, it's up here above the x-axis, so obviously it needs to be positive. So our answer is 6. So it's not negative 2. K is equal to 6. Okay. Right, that was 2.2. 2.3. Determine the equation of BC. So BC is that line over there, in the form of y is equal to mx plus c. Okay, so what we do is, because we now have these coordinates, we have that coordinates, we can determine the gradient and then also substitute one of the coordinates into our straight line formula. So let's start off by finding the gradient. So the gradient of BC would be then 6 minus 0 over 0 minus negative 8. And that would be 6 over 8. If I simplify, that's 3 over 4. Okay. So now coming to my straight line formula, I'm going to substitute. Let's substitute. Doesn't matter. Let's substitute B 0, 6, and our gradient. A gradient of 3 over 4. So y will be 6. Gradient is 3 over 4. X is 0 plus c. So that falls away. That's 0. Yeah, I was a bit silly now. Okay, but anyway, so that is 3 over 4 x plus 6. Okay, so we could have actually just stopped here by the gradient, né? And then we know the y-intercept there is already at 6. So we knew what the gradient is. Okay, after we find the gradient, we actually know what the coordinate of c is. So yeah, but nonetheless, we got our answer. Okay, 2.4. Okay, calculate the size of theta, so that angle of inclination there. So the formula to determine the angle of inclination is tan theta is equal to m, the gradient. But now this is a rectangle, right? Yeah? So the opposite lines are parallel to each other. We don't have these coordinates, so we can't find the gradient of this line, but it would have the same gradient as BC, yeah? Because they would be parallel to each other. So we can use this gradient to plug into that equation to find theta. So we can say tan theta is equal to, and that gradient of CB, we found it in the previous question, and that was 3 over 4. And then we say tan inverse of 3 over 4, and theta is equal to, give me a second, 36,87. 36,87 degrees. Okay. Right, 2.5. Calculate the area of ABCD. Calculate the area of ABCD So what we can do is we can just find, seeing that we have 5, we can determine that length and then just multiply length times breadth. Okay, so the distance of BC the distance of BC, x minus x, so that would be 0 minus -8 squared plus 6 minus 0. So this would be 8 squared, okay, let's put it there, 8 squared plus 6 squared, that would be 64 plus 36, which is a square root of 100, which is equal to 10. So area of A, B, C, D is length times breadth, which is 10 times 5, which is equal to 50 units squared. Okay, 2.6. Calculate the size of BAC, so that angle over there. Yeah? So we know that's 10, so we can use some trigonometry to find BAC. So if that's my reference angle, I'm working with the opposite and the adjacent, and that is tan. So I will say, let's make that angle A. So tan of A would be 10 over 5. Then I say tan inverse, 10 over 5 is 2. So I say tan inverse of 2 is 63,43 degrees. And there, 17 marks.